Well, hello everybody. It's good to see. I was good to see actually a lot of you come in. I wasn't sure how many people would show up. Usually whenever I do Zoom reviews, it's like four people. So this is nice to see that it's like a lot more than that. Um, if you guys see me like mute you or anything like that, it's nothing against you. It's just, if I hear you, I just end up muting you. So I'll probably end up muting Melanie for a second. It's just because I see here's this background noise. Um, and And so just to kind of get into this to really talk about what I was kind of thinking. And obviously, when anybody wants to interject and say anything, you're welcome to input, because it's much, I have a sort of a plan, but I absolutely can change depending on what the needs of all of you is. Being that this is an exam review for you guys, it's not, I don't need the exam review. It's always for you guys. Um, so
I
let me
guess
start with like just going through like which I probably showed everybody in lab or showed everybody in some form or another, but it's never a bad thing to kind of just go through what I have on Canvas, just so that like that way everybody is aware of what is available at the moment for studying. So just kind of going from the basics. So let me just share Canvas real quick, and then so the first thing is looking at what I have on Canvas. So I always put a study module for you guys together on every single test. So for this one, right, with exam number one, I have a study guide that is kind of below all the chapters. So this might look different between Monday, Wednesday, and between Saturday, just so people know if there's any Saturday people here. It will still say exam one study module, might be in a different spot. So the first thing is when you're kind of going through this, what to do, how to prepare for this. Usually, what I always recommend for everybody is, obviously go through the study guide, which is never a bad plan. Go through your notes, just kind of read through everything that you've been writing, like go through the topics, just to really refresh your brain as much as possible, especially probably for those first 2 or 3 weeks of the semester, right? We're already on week five, so you kind of realize how much you probably might have been like, oh crap, yeah, we did cover that. And you're going to hopefully realize that, oh, that's actually a lot easier than I thought it was back then, because now you've been using it a lot more. Like sig figs, for example, or unit conversions. Hopefully they're getting a little bit easier. They're probably still hard, but hopefully they're getting easier. Um, so with this test, it's chapter 1 through 4, so which is everything from the first 4 weeks of the semester for the most part. Um, it's going to be multiple choice, so it's going to be 30 multiple choice questions. You get about the lecture period length of time to complete it. So usually I say the time's about 75 minutes, just so it represents whatever length the normal lecture time is. Um, so, and obviously if people get done earlier, we'll end earlier, but there's always people taking it the whole time, and there's no rush if you are like going up to that time. No one's kind of thinking none the wiser. And while I'm doing this, I'm just trying to figure out where the heck did my chat window go? Oh, here it is. Sorry, I just want to make sure I had it up. Um, so you're allowed to have obviously calculator, pencils, all that stuff. If you need scratch paper, usually I always have a bunch with me, but you're able to write all over the test. There's at least one blank page in it that you can write on. So usually people are fine when they're going through it. The reference stuff I'll give you is pretty much the yellow sheet. The only thing I just took out a couple things that you don't need, just so it's not like distracting you guys while you guys are doing it. Like all those constants that are on like the top right hand side of the back page where all the conversions are, like you're not going to use any of them, so I took it out. um what else? Let's see. So there's a study guide here. So I would recommend like just skimming through it, going through all the topics, making sure you're kind of recognizing everything. And if there's something you don't, whether you print it out yourself or if you want to, even just make notes in your notebook, I would go through all the little things. So I kind of try to boil every week chapter down into, I try to make it less than 10 bullet points, was really the goal. So, which for the most part sort of succeeded, which is nice. It's only 2 pages. Um, Probably when I first started Chem 3A, this thing was like 6 or 7 pages long, so I'll take it. It's a win. It's a lot shorter. And the way I made this thing too, it's based off all my old exams. So essentially, I took all the major topics that I've ever tested on, and I put on here, and then I just included like anything else. So I'm like, well, this is important, but I never tested on it, but I still think it's important. So I put all those key things here, so that way it's not anything that's, I don't know. I never try to trick my students. It's not something out of left field or out of nowhere where it's like, oh, he never showed us this thing. Like, and there's no questions like that. I don't see a point in doing that. It doesn't make sense to do it. Maybe if this was like a higher level course, sure, I want you guys to think about things, but it's introductory chemistry for a reason. It's meant to be introductory. It's not supposed to be this terrifying event. Um, that can happen, right? There's a lot of teachers that will make it into that, and that's not my goal. It's to make you just know enough so that way when you get to physiology or microbiology, for all of you guys taking it, that you know enough so you're not struggling in that class, right? Or if you have to go into Chem 1A if you're a biology major. Um, so the other thing too that I have here as well to point out, which some people might not have realized, is if you're like hungering for practice problems, which some of you keep like asking me for more and more and more. I'm like, oh my God, I've given you so many things to do. How do you need more? So if you need more, I included problems I recommended out of our online textbook, right? That's linked onto Canvas. So it goes to each chapter, and I try to pick the ones that do have the answers in the at the bottom of the page for those online questions. And if anyone needs me to show you where they're at, where the online book is or any of that, I can do that too here in a second as well. But I did it for like each chapter. So one thing I always kind of recommend doing is like practice whatever you're struggling with the most. Probably for a lot of you, that might be unit conversions and dimensional analysis. We'll talk about that in a second. Really, how crazy will I get with these problems? Not as crazy as the homework, just to kind of make you guys hopefully feel a little bit better. It's never going to be as hard as the homework, just so you know. It's always going to be easier, being that you did the hard part. Now just show me that you know the basics afterwards. That's usually what I would say. So I would recommend trying this problems if you need extra help. Other than that, though, so going back to the study module, there's a couple things you can do to prepare. The first thing is I have two practice exams here. So disclaimer, one of them is harder than the other one. Are we able to use your notes? Not on the first test. On some exams, I might let you use like a note card, or maybe your notes, but not on any of the not the individual tests usually. Not for this one. And usually the reason I always say why, because it's like, oh man, notes would be so helpful. Why not? Well, the thing I learned, through my short time teaching is whenever I let people use notes on the first test, it ends up being a nuclear explosion of failure on the second exam or maybe the third one. And the reason for that is because you need to know the fundamental skills from weeks 1 through 4 in order to do really well throughout the rest of the semester. So one of the things I always kind of explain to all my classes is chemistry especially is very much it's like a tower that you're building up throughout the whole semester. And if you have a really crappy foundation, that tower is going to fall right over. And this is definitely one of those classes, right? And it's not going to be this impossible test or anything. You don't have to memorize like a whole textbook or anything. But it's just like, can you apply those basic unit conversions? Can you read the periodic table? If you can do those things, you'll be fine. You don't need any, if you need a formula, I'll give it to you. If you need something that's like out of the ordinary, I'll give it to you. It's nothing that the resource you have available, you should be able to solve it. So for the person that sent me that question. But going back to this though, I would recommend doing one of the prac exams soon. So depending on if you're taking it Monday, or for the Monday people, like I would take it the next day or two. Try it and see how you do. If you're Saturday, you definitely should be taking these like tonight. Um, and the reason I tell you guys to take them sooner, rather than waiting till you study, is as I tell everybody, I want you to take a practice test and I want you to essentially fail your practice test. I want you to take it like it's a real test. And, maybe when you take it, you get 100%. Amazing. Your job is done probably. You already know probably the basics. But the reason I say I want you to not do as well on a practice exam is because it shines a light on anything you really don't understand, which is great. That's good. That's good to know. See what you don't know because it gives you that chance. Was there a question there? I heard the voice for a second. But it helps you kind of see, is there, what can you study? So when you're going through it, just write down anything that you're like guessing on, anything that you're not entirely sure for. So that way you can go back to that thing and review it. The practice tests, keep in mind, they're not this rotating question bank. So it's literally my old exam from practice exam one's from fall of 22 and exam number one's from fall of 23. So they're two older tests that I've given to students who were in your position before. Exam one is a little bit harder than exam two, just as a warning, because when I first got here, I was like, let's push everybody to the level of like my grad school education, which is a top 25 university. Yeah, everybody's gonna be fine. And that was a little tougher, a little tougher. Um, and so I kind of, brought it down more to where this level is. I was thinking more majors level is where I put it, and that was a little harder. Um, so I would recommend trying it, see how you do on it. And once you map out all those things you don't understand, well, that's when you go study, review your notes, go through it, and seek out practice problems to help you. Whether it's going through the study guides, or you also have the option of in some of the different modules, so for like different weeks, there's practice quizzes at the bottom of multiple of them. So like for example, after week one at the very bottom, there's practice quiz number one, right? So that's something like it's pulling from like a bank of like hundreds of questions for you to do your conversions and go through all your units and all that stuff. And I was asked, can we use a conversion sheet? Yes. So you'll be getting the yellow sheet. It has all your conversions on it. So you will be able to use the yellow sheet, but it's going to be like, it's not going to be yellow. It's going to be white because, or whatever color exam you have. So it's going to be the color of your test. So for the different versions of tests, there's like, I don't know, I've made way too many versions. There's what, six or how many sections of Chem 3A? So there's four sections and there's like eight versions. I don't know. There's a lot of them. So whatever color you have, that's going to be the color of your periodic table. But you will get it. So you'll have the practice quizzes. So I'd recommend trying them. Like I think there's three of them I want to say that exist. So there's one at the bottom of dimensional analysis. There's one at unit conversions. And then there's one I think for atoms, I believe. Maybe it's at the end of chapter 3 and 4, week 4, probably. Yeah, there it is. So there's three of them, and I believe I put a nomenclature one in there too, if I remember correctly. I did. Okay, so there's four of them. You have actually four different ones that you could be playing with. Just keep in mind that practice quiz number 4 talks about covalent naming, and there's going to be no covalent naming on this exam. Just so you know. Will we need to bring our yellow sheet or will you provide it? Sorry if you already mentioned it. I will give you one. So just to reiterate that, I will give you a brand new one. So for any test, if there's a reference sheet that like if there's not a note card type of stipulation, I'll give you a blank one. So keep that in mind. If you've been using yours and it has 300,000 notes on it, you got to make sure you remember all the things that you usually use, right? So keep that in mind. So like predictable charges is a big one, right? A lot of you have them written down on there, or maybe you're using the white periodic table. Make sure you know those ones. They go by the columns, so it's usually pretty easy to remember that. Will we need our green sheet? Really good question. There is one I think it's just one polyatomic question. So, and I'm not giving the green sheet, but just to let everybody know, it's one of the eight ions, and it's from the top row of the sheet. So if that eliminates it down to five of them. So remember those five, you'll be fine. That takes out 99% of that sheet. So if you know that top row, of the oxyanions, polyatomics, you'll be fine. Or remember the T43 method. You should be starting to memorize them anyway, just so everybody knows. I would recommend you memorize the polyatomics for exam 2, 3, and beyond, because you will need them when you go to physiology. I'm shocked at how much they're used in physiology. I I thought I figured I was like overselling it before, and now I'm really selling it because I'm like, oh my God, I'm hearing from my old students how much they're like, oh my God, they're in everything. Ah. So, um, you make sure you start memorizing, put them on flashcards, but for this exam, only the top row of the top chart. So like where nitrate is, carbonate, that row, I believe is what's on that one. Like borate, it's like whatever else is there. Um, what else? What else can we do in terms of studying? You're always welcome to rewatch videos, right? That's always the option for you. If any of them are scored and you want to improve, like let's say you didn't get the high enough score or weren't getting enough things correctly, you can always go back to them, the ones that are scored. They never close at any point in time. Really, the only time I start closing those things is like finals week, right? When it's all the assignments are due and the final happen, and then they close. Until then, you guys can open them up at any time to review anything, so there's always an option. If you're like, oh, I don't really feel like going through all the questions, there's the same title on YouTube. So on my channel, you're welcome to go through there as well. So you have that option too. So I always recommend that. The other thing as well, a lot of people don't know is that you once you're finished a homework, you can always convert it into what we a practice homework as well. So once the due date passes and you don't have a late pass out, just so you know, you can tell it to turn it into a practice version. Just keep in mind once you do that, it locks the homework grade in. So if you're not done, don't do that, okay? It's only if you're finished. So if you see like, oh, you got you're 90% and above on your homework, and you're like, I'm done. Then you can do it as a practice. Okay, got another question. Juan asks, when you have a chance, can we go over homework? I especially need help on question 5 on our current homework. Sure, we can talk about homework. We can go over whatever you want. Like I said, this exam, if it helps you review for the exam, I'm okay with it. Um, sure, we can do that in a little bit. So those are kind of some of the things that you have available to you to study. So that alone is probably the equivalent of 500 practice problems easily, if not more. So there's a lot that you could use to study. So practice problems is really, oh, did that? Oh, just not shared. That moved. So practicing problems is really the thing that I would recommend kind of the most for you to do because that will probably help more than anything else. Will we have test questions with multiple unit conversions and one word problem? That's a really good question. So going off that, so one of the things that the chemistry department decided about, I want to say a year or two ago, and more and more of the faculty are starting to finally do it. I was kind of one of the first ones to jump on board with this because I was the one pushing it more than anything, is when it comes to unit conversions, we really try to make it so that they don't go over two steps in terms of two conversions on exams. So you can think back to all the homework problems that you've had that have like 5 conversions, 6 conversions in a row. The goal is to break them down so it's only 1 or 2 steps in terms of conversions. So, meaning, for example, what do I consider a 1 step conversion? Grams to kilograms is a 1 step conversion. Milliliters to liters, using density maybe to go from grams to volume, right? Using density. That's a 1 step. Um, 2 or more steps is typically dimensional analysis. So if you had to, um, well, I guess kind of, well, not all of you have done this lab. I'm trying to think of lab examples, but maybe a 2 step would probably be like if you go to think of the density lab, you did the displacement method, right? You took that little metal object, you threw it in water, it changed the volume. So when you did that, you had to take the difference of the volume. So you had to do 1 step there, right? Subtract the two values. And then you had to plug it into the density equation. So mass divided by that delta V or change in volume. That's 2 steps. So most of the math problems are no more than that. So if at this time you've all been doing conversions that have been like 3 or more steps for most of the homeworks, and if you were able to get through those, you should have no problem getting through a 1 or 2 step problem, which is pretty nice. So the way that I treat my tests is, can you do the fundamentals? If you can do the basics, then you will get an A. it's you should get an A. There's no reason really you shouldn't, as long as you know those core concepts. Like, can you do the basic conversions? Can you do a simple swap drop? Can you tell me how many valence electrons there are? Can you like do these little simpler questions? A lot of the times it's nothing. Are we gonna have an empty periodic table? Oh my God, that sounds horrendous. What do you mean like literally just blocks and then nothing in it? That's a good idea. Sure. No, I'm kidding. That's not what I'm doing. No, that's what I had to do when I was a chem major. Like we had to fill out our periodic table at one point, like from just the blocks. So I had to memorize the thing at one point in time, and that's including the mass numbers. Um, I forgot probably 90% of it. Uh, it's- but no, I'll give you the yellow sheet, so you don't have to do that. Can we go over how to create formulas? Absolutely, we can do that too. Let me start writing down some of the things that you guys want to talk about so I don't forget. Um, yeah, and if at any point you guys have topics that you guys want to go over, I'll start writing them down. So that way we had it. We had homework for question 5, and then we had do formulas. God, I can hear my voice, the worst. Okay. All right. That's crazy. Well, it wasn't okay. I shouldn't say it was the entire thing. It was like the first 4 rows, first 4 or 5 rows. Can we go over unit conversions? Yes, absolutely. So we have kind of two options. So it's kind of up to you guys. Obviously, if you don't want to, we don't have to. So I could always do a poll to see what you guys are interested in. I do have a Kahoot that maybe some of you clicked on already in the exam review, which I think Kahoots are fun because it's something you guys can play as a game. And I made one of another old exam into a Kahoot, so it's a multiple choice thing. I'm gonna do a Kahoot. Sure, we can do a Kahoot if more people want to do it. That's fine. So I made one of my old tests into a Kahoot, which will go over pretty much, I would say all these topics so far. I don't remember what question 5 on homework 4 is, so let me pull that up real quick. And then, is there any other things? Is a Kahoot similar to, I mean, it is an old test, so I don't know how much similar I can get. Just keep in mind, yeah, I can give you practice tests. That doesn't mean they're going to be the exact same questions. It's just showing you what I've tested in the past. It could be different. It could be the same. It could be just maybe different numbers. That is possible. There's only so many things I can ask you, realistically. Um, One of the things you realize in homework is a lot of times it starts repeating the same problems. It's just different numbers or going backwards. So keep that in mind. There's a limit to how much is possible to be asked. So while you guys are thinking of topics, oh, I see what question 5 is. Question 5, I don't know if that's on the test. I don't know if I put any of that on there. So it's like the pure element, pure compound mixtures and stuff like that. I don't mind going over it, but I don't know if I did put it on the test or not. I can't remember. Okay, so it looks like a couple people are okay with the Kahoot. So let me pull that up. So and then we can do it. And then as we go through problems, like the way that I do my Kahoots, it's not just you guys just playing, seeing how they go. After every problem, if I see like clearly there's a lot of people that aren't getting stuff, we'll switch to my tablet. I'll kind of write it almost like as if it's like a normal YouTube video, and we'll go through it and how to do it. Okay. So don't think I won't take this as escape. And when we're kind of going through it, cation, anion, Bohr model, and word problems. Is that what you mean by word models? I'm assuming you mean word problems. Um, Word problems, yeah, sure could. Word problems, yes, that could be a thing. In terms of would there be anything with the Bohr model? It's actually kind of hard to do something with the Bohr model on the exam just because it's something that like in order to put it as a multiple choice, it would have to be like kind of like my videos where I would show you something. You got to tell me how many electrons. I actually really don't do many Bohr model things. The reason is because it's the starting point, right, of how to look at the electrons. So it's more on electron configuration, how to count valence electrons, and I think there's one orbital diagram problem I think ended up on there. And it's like still in the same vein. It's like, okay, here's orbitals. Can you tell me which one's correct? Or can you tell me which element is it, right? If you see all the arrows, could you be able to tell me if I give you the orbitals and I give you the arrows, could you tell me what it is? Um, so that like that kind of problem. You got to remember it has to be multiple choice. It can't be something that you got to draw, right? So keep that in mind too. I don't usually try to hide. Like when I was a student, I was very similar to you guys when I first did chemistry for the first time. Oh my God. I'm actually kind of surprised. When I talk to a lot of people that I was friends with at that time, they're shocked that this is what I teach. Like, because it was tough. The teacher that I had it with, she was a first, bless her heart, she was a wonderful person, but it was her first time teaching it, and she didn't really kind of know how to teach in high school at the time. So it was kind of a mess. And yeah, there's a lot, especially how much math there is. The math's the hardest part. And for a lot of you, you guys haven't seen the algebra probably in years for many of you. So that doesn't help at all. So it's tough, but it's doable. It is doable. You guys got to remember that. I wouldn't I I would tell you. I would tell you if I'm like, oh, I mean, when we do this game and I see like how the results are, I'll tell you if I'm like, I'm nervous. I'll be honest, but you guys are capable of doing it. You have to believe that though. I can tell you all day that, and I do believe it, but you have to too. All right. At any point when I start this thing, you can join at any time. So if you get kicked out to the internet or whatever, um, you can always rejoin. Just keep in mind that, might make you do a new profile if you have to connect to a different device. So if your device is at like 10%, probably pick another one. Pick an iPad or something, or I don't know, do it on your TV or something. All right, here, let's start it. I think this goes in order of my last test. Well, I guess we're starting with double points right off the rip. All right, so the correct scientific notation for the following number is what? So one of the things you have to do is scientific notation. Um, and when you kind of do these problems too, you can try practicing counting your sig figs. You can as well. It's never a bad idea to see if you can just guess, and you can always look it up, if you want to check your answer. And then while you're doing this review too, you're welcome to use your notes, obviously. But if you want to treat it like it's the test, then don't use them. See how you do. Be honest with it. I didn't see how many people signed up, so we'll kind of let see how the timer goes. I know it was at least 13 or 14 people. Okay, good. Okay, most of you guys got this one, which is good. So with this one, so it looks like mainly people were stuck between two different camps with this one. So the first thing is making sure with scientific notation, the biggest thing is that it has to show your correct sig figs. Meaning that's kind of the beauty of scientific notation is that it should show you the same number of sig figs as the number did. So, being that when we're counting this thing and looking at the value, right, when we start counting significant values, we start at the 5, then we count the sandwiched 0, right? So that'd be 2. Then 2 would be the third value, then 1. Then we have a trailing 0. Now, that's where everybody is usually like, is it significant? Is it not? Well, it depends. If you have a decimal value, then it is. In this case, it's a very tiny number. There is a decimal, so therefore it is significant in this case. Okay, so it's one thing to kind of pay attention to. So we should have 5 sig figs. So that's why for the person that picked yellow, you were really close, but make sure you have that extra 0. And then for the people that picked red, um, so when it's small, right, it's 10 to the minus 4. So one trick that I taught myself for how to know if I ever do these right is plug your scientific notation answer, plug it into your calculator and see what you get back. You should get the same decimal value, right? So meaning like if everybody right now plugs in 5.021 times 10 to the negative 4 into their calculator, they should get a decimal value back. And that's like a trick to use your calculator, which you have at all times, right? You have that during a test. So it's like I don't know if I feel like it's cheating, but I think it's using your resources. It's what you're allowed to have. So it's a trick. And the same thing even with the big number. If you put 5.021 times 10 to the 4, you'll see that it's like 50,210. So it's a lot larger than the original number. So on the exam, what is on the reference sheet? It is the yellow sheet. So it is everything on the yellow sheet except for the constants. You don't need them on the test. That's why. Okay, so this is actually Monday, Wednesday. You guys did this week. So you guys did a lab with this. So suppose a thermometer marks at every 1 degree increment, and the mercury level in the thermometer is exactly between 25 and 26 degrees. How should you report the measurement? So keep in mind, they're not just important just for this test, but really for the lab practical at the end of the semester, right? A lot of people forget that you do have to know your lab skills. It's one of our agreements with the nursing program, rad tech, dental hygiene, and respiratory therapy is that you have to know your lab skills prior to being allowed in this program. So I need this class with a C or above. Um, is because your lab skills. So knowing the basic measurements is key. Okay. So with this one, so how do you estimate digits, right? So it said that the marks, so you go off those tick marks, and it said the tick marks are 25 and 26. So that means that they're every one essentially. Now, when you probably see the actual thing, it'd probably be a little easier because you see like 25, 26, 27, 28, and so on, right? So you always estimate one past whatever the tick mark is. So being that you see those single digit numbers, that means you do one decimal place in this case. So it'd be 25.5. For the people that picked red, how would you see that? That's kind of like our grad cylinders. The values are every zero point 0.1. So you'll see like it'll go from and this is talking about the 10 milliliter grad cylinders, not the 100. The 10 milliliter grad cylinders, you'll see it goes between 1 and 2, but there's 10 lines in between 1 and 2. So that's when you go that extra spot. And just so everybody knows, so for later, I mentioned that there's a team assessment after the exam, which is kind of like a test, but it's low stakes. You get your notes on that. So that's the thing afterwards. So make sure you do bring your notes to your exam day. And one of the things that I'll have in that room when you do this team assessment is there'll be some stations that could be like this, where there might be a thermometer in front of you, and you just got to tell me what's the reported value. So when you write down your answer, um, so could be a free question on there. That I can tell you that there probably will be a thermometer one or a volume thing or something like that. There are exactly 2.54 centimeters in 1 inch. When using this conversion factor, how many sig figs are you limited to? I got my editing cut out for this video in between all these sections with no talking. Oh. All right, so with this one, so what do we think the answer is? I'm assuming we're probably waiting for that last person. So you got 4 seconds to put your answer in and lock it in. Okay, so we were between 6 and 10 for number three. Ooh, so why is the blue one right and or the teal blue one right and not the people that pick three? Because honestly, it looks like 2.54 is three sig figs. So why is it exact? Well, if you look at your yellow sheet and you look next to that conversion, it does say the word exact next to it. And you are converting into inches, you're right. So you would think that doing centimeters to inches, you should do the sig figs. And usually you're correct. But there's only two conversions, I believe, that are on that sheet from US to metric that do have the words exact next to them, which means that they're an infinite number of sig figs and they don't affect your numbers. And that's because that's a measured value. That's a perfectly, no, I shouldn't say it's a measured value. It's a perfectly converted unit so the systems can be bridged somewhere. So then that's one of them. I think the other one's in joules, I believe. I think it's like one of the joule conversions is the other one, but we don't really see that one in this class. So it's only this one. I just wanted to kind of see like, hey, do you know what that exact means whenever you see it? So you ever see the word exact? That's telling you, hey, this is the value. So you can report the sig figs however you want. It does not affect your final answer. Your measurements do, not this conversion. How many that should say dose. Sorry, typos are real. How many low dose 81 milligram aspirin tablets can be used from 1.21 kilograms of aspirin. So a lot of you guys are interested in doing, all the nursing stuff. So it's a little conversion one. And we'll do this one together. So afterwards. And when you're kind of doing the test too, so you might have saw I put a longer timer on this one, right? Some problems, the math ones obviously will take you a little bit longer to do. Um, but when it comes to the um the theory questions, maybe on just counting electrons or whatever simple things, hopefully you get those ones in like a minute or 30 seconds or something, because hopefully you just kind of know it, or how to do it right away. So it's okay if this one's taking more time. It's balance. I try to balance it so that way it's
All right.
doable. So we are doing our first question. So we have question number 4. So it's the one that you guys were just looking at. So it says how many low dose 81 milligram aspirin tablets can be used in this one? So the first thing that I do whenever I look at any of these, right, is I highlight all the numbers that I'm giving, or I underline them, or whatever. And you can have multiple pen colors if you want on your desk. If it's something that you do as well, I don't mind. So I got one here. I have the 1.21 kilograms of the aspirin. I have 81 milligram aspirin tablets as well. So I got two things here. Now, the tricky part with this one is probably kind of the way I kind of wrote the question isn't maybe the most obvious in terms of what conversion factors exist here and what's really by itself. So when you're kind of looking through these, you got to define what the different numbers represent. So we have 1.2 kilograms or 21 kilograms of aspirin. And then you also have how big the tablets are, which whenever you're talking about tablets, that is a conversion because it's referring to like 81 milligrams in a tablet. If you look on any bottle of aspirin or any type of you know, drug in your medicine cabinet, their milligrams per tablet is how they're defined. So when we use that word per, that's telling you, hey, this is a conversion. I should have worded this problem where it had that so it defines it, which is something I made sure that that was the case on the test. So don't worry about that if there's something like this. So when we're doing these, we always start with the thing by itself. The other one is 81 milligrams per tablet is the other thing, right? Because you're trying to figure out how many tablets are there. So that's where, where that tablet part comes from. So the thing is you need to do is we need to be able to cancel our units. We got to let the units kind of guide our thinking. Yeah, it is kind of tricky. It's kind of the way it's worded though, to be honest. It's not, like I said, it's not the best worded problem. So what can we cancel? So do we have any matching types of units that you see? Is there anything that's matching? And the one thing that hopefully you're kind of saying to yourself, or maybe you're trying to frantically type, is the grams, right? So that's showing you, hey, there is a bridge here. Can you define it, right? And that's where you got to use your yellow sheet to do that. So when you're going through that, you have two options. You can either go straight from kilograms to milligrams, which if you're really good at unit conversions, go ahead, you can do that in one step. Most of us, though, including myself, I like to make it a little easier by doing two steps, meaning that I go from kilograms, then I go to the base unit, grams in this case, and then I go out to the next prefix. I always go to the base unit first, and then I go back to wherever, because that's what's defined on your sheet. That's what you know. It's what you've been practicing all along. Like, stick to what you know. Don't try something fancy. Unless you don't know what to do, then okay, sure, try something fancy. But ideally, you stick to what you know. All right. So the first thing is if we have 1 kilogram, how many grams are in 1 kilogram? Can anyone tell me? What do we got? These are hopefully things you kind of just maybe know. I don't know. Hopefully. I know it's back to the Zoom days. No one wants to type anything. Oh God, we're living the pandemic here. So if you have 1 kilogram, we would have 1,000 grams. It's also late. You guys, half you had class too, so I don't blame you. and work. 1,000, thank you. So you have 1,000 grams and 1 kilogram. Right. Now from there, we want to go to milligrams. So if we do that, 1 gram is equivalent to 1,000 milligrams. Okay, great. So does it all cancel so far? Well, we can see kilograms cancels kilograms. Awesome. And then we got grams cancels grams. So our units are guiding our thinking. That's the goal, right? Can you set them up so that way they always cancel? Are they opposite of each other is the idea. Now, how can I now integrate the tablet thing? Well, I had this conversion from earlier, which was milligrams per tablet. So if I set it up to let my units once again guide my process, so if I want to cancel milligrams, it needs to be opposite in order to do that. So if we do that, right, 81 milligrams is on the bottom, we'll see that being that they are opposite of each other, let's use another color, they are opposite, they will cancel. So we can then put tablet on the top and then carry out our math. And we should get our answer that we have a absolute ton of tablets when you go through this. So how do you do the math? Just sort of a review in case you've been lost on this for 4 weeks. You always multiply what's on top and then you divide what's on bottom. So we would do 1.21 times 1,000 times 1,000, hit the equal button on your calculator, divide by 81, and you'll have your answer, which in this case was 1.5 times 10 to the fourth power. So it's done in 2 sig figs because of the 81 milligrams is 2 sig figs. So if you picked dark blue, then you got it correct. Okay. So that's how you do that problem. So this one is probably like on the this would be considered like the hard dimensional analysis problem if it were be on this test. It's arguably you could say it's 2 steps just because it's going still in the first 2 steps are kind of you can put them together. But it would this would be like if you'd probably get like one of something like this. Not maybe not this problem, but one of something like in this realm, right? Of conversions. Okay, let's go back to the thing. And if anyone has any questions too, so I can always answer them too. So keep that in mind while I try to bring this back up. All right, so for the next one, all right, so this one's more of a one we covered for Monday, Wednesday. We covered it on Monday. For Saturday, this was in last week's last video, if I recall, is the number for that one. Okay, so okay, we were between the two sides of the periodic table. All right, so that's good. When it comes to these kind of questions, right, you're looking for the extremes in terms of position. So I'm happy that people were getting down to that. Because it's when you start kind of picking things in the middle, that just tells me you have no idea, right? At least you're kind of using your reasoning. So what does ionization energy mean? So let's talk about that definition for a second. Ionization energy is how much energy is needed to remove, right, an electron. So what thing is out of the two that were chosen, right? You guys chose sodium and fluorine. Which one of them has a positive charge? So thinking of that, right? One of them has a tendency to have a positive charge, which means that it's really easy to remove that electron, is what that tells you, right? So sodium, right? Anything on the left-hand side of the periodic table has a very low ionization energy, for the most part, except for hydrogen. Hydrogen's is pretty high, but all the metals, they have a very low ionization energy, which is why they have a tendency to be like sodium plus or cesium plus or any or potassium plus. That's when they make those ions. And the other thought process is think about the octet rule. What's easier? Is it easier for it to lose the 1 electron or for it to gain 7 electrons? Gaining 7 is pretty hard, right? Can you find 7 other atoms that are willing to kind of give you a handout? One way to look at it is like, is it easier for you to give away $10 or convince 7 of your classmates to give you $10? It's probably gonna be a lot easier for you. Someone's gonna take the $10 off you, no problem. But to convince all your classmates to give you that much money, it might be a little tough, right? And that's kind of the thought there, is a goofy analogy. So fluorine really only needs one, so it's not willing to lose those 7. The other reason too is if you think of the atomic radius trend, if you remember as it went across the periodic table towards fluorine and the noble gases, it got smaller. So being that it got smaller, that means it's really hard to rip those electrons away because it's really close to the center. So the two trends are related to each other, if that helps. But if you haven't really studied it yet too, just kind of maybe write down periodic trends. So if you were to think about a length, right? So starting off the basic, because you got to derive the cubic conversion. Well, if I have, let's say, a line and I were to define it, well, the line, let's just say it's 1 meter. Well, how many centimeters is 1 meter? Well, when you look through your periodic table, or not your periodic table, your conversion sheet, you'll see that it is 100 centimeters is in 1 meter, right? So that's where the centi 100 comes from. But we want to cube it. So what do we got to do? We got to start to build towards a cube. So what's the first thing you do? Well, let's say if you are measuring a floor, right, the square footage of something, let's say it's a 1 meter by 1 meter box. Well, then you'll have something like that looks like this, right? So it's 100 by 100. So if we want to find the area, all we would have to do is say is, oh, I'm going to take 100 centimeter times 100 centimeter, and that's going to be the equivalent to what 1 meter squared is. So when we do that, well, we're going to get is 10,000 centimeters squared is equal 1 meter squared. But we don't care about squared. We want to know about cube. So what do? Well, what we can do is we can add a third dimension. So we'll move our little conversions here, and we will add the third dimension by making it a cubic shape. At least the best of my drawing abilities. I'm the best artist, as all of you guys see in my videos. All right, we have our cube, right? And so we'll add that third dimension, right, which is another one. So what are we going to do to what we had before is we're going to multiply it by another 100 centimeters. And what you're going to get is you'll have 1,000,000 centimeter cubed is equivalent to 1 meter times 1 meter times 1 meter, which is 1 meter cubed. So that's your conversion. So that's what we're going to use in this case. So now it doesn't have to be that long. This is why I kind of don't put it on there because it's really long and usually you don't use it for anything past the first two chapters. But it's still it's a good unit conversion practice. It actually is probably one of the best ones. I always tell students, if you can do this conversion, you can do any of them because I think this one, in my opinion, is the hardest. I think. That's why I don't put it in there. I think it's hard. So we'll just plug in our things, right? So we had 1 meter cubed, and that's equivalent to 1,000,000 centimeter cubed. And then you just multiply them. So then you'd get 2.5 times 10 to the sixth power as your final answer. Okay. So that's kind of how you do it. And then you see your units cancel too. So it's kind of hard, but it's only hard if you don't know how to get the unit conversion. You can do that for any of the units. So whether it's meters, centimeters, decimeters, whatever, you can define it that way. Okay. So anyway, I'm sure that probably bored everybody to tears, but let's go to the next question. So that was question 6. All right, let's go on to another one. Okay. When an atom gains an electron, the resulting particle is called what? Right. So this is the basic. This is the real basic. So hopefully you know this one. Um, this one's easier to probably get it flipped between its counterpart. It's gaining an electron, so that's the negative one. So cation is positive. Anion is, I think of onions because onions make you cry when you cut them. So anion is that would be that one. Might have been misleading because I led it off with cation and probably people clicked right away. I wasn't finished talking about it. But this would be the anion would be the correct answer. Which of the following is a heterogeneous mixture? So, oh, okay, never mind. There it is. There they are. So these are just words. So you got to kind of go off the different things that are here. And like I said, if anyone has questions about anything, please, please, please type it in the chat at any point. Don't be afraid to. You can also direct message me too. A lot of people have been doing that, so it's fine. Um, I don't I won't be mad if you send it to me too, if you're too afraid for 20 some people to read it. And probably one of the things too is your question probably benefits everybody because everybody here wants to learn and wants to do well on the test. So, and if anybody's wondering, this is one of those things that, I've been saying that I have a Excel sheet that has what everybody does and goes to, like Grasp BTC and all those things. The Zoom reviews are one of those things. By the way, your heart's racing. Oh no. Oh no. Oh no, I'm sorry, but I'm looking at the yellow sheet. I don't see how you got 1 gram for 1,000 milligrams. Okay, that's actually a really good question. So the yellow sheet does the opposite conversions that I usually use, meaning that it's the flipped form. So the yellow sheet does 10 to the negative 2 grams is equal to 1 centimeter. So it's like the opposite of what that is. So, oh boy. All right, let's talk about this and I'll talk about the conversion thing that you asked me about. All right, so with this one, oh boy. Wait, did I select the wrong answer? Oh, I selected the wrong one. Oh boy. Okay, so the right answer here is not air. That's definitely not air. Air is a homogeneous mixture. I clicked the wrong answer, so I apologize for the people that didn't get credit and that did, I guess. So air is a homogeneous mixture. Why? Because you can't physically pick out the different pieces. So, in order for it to be heterogeneous, it has to be something that you can physically separate. So, if you were to go through those, so let's say if you go through milk and not spoiled milk, regular milk, you can't just easily separate like all the fat and the water and all those different things, right? It's just this white liquid. You really can't tell the difference of all the different parts. Sugar water, so that's just like if you take like coffee and you put sugar in it and obviously you stir it, do you see the sugar that's in there? And usually no, obviously if it doesn't dissolve, that's another thing, but usually it dissolves. So that would also be homogeneous. Raisin Bran is referring to the cereal. This is why I don't use this question anymore because I get like 10 students that I guess don't know what Raisin Bran is, which is I figured Fresno has raisins. I figured people would know where raisins are and the cereal. I was very wrong. So Raisin Bran is a cereal. It has raisins and then the you know cereal pieces, and that one is a heterogeneous mixture because you can pick out the raisins if you hate raisins. So anyone that picked yellow is picked the correct answer. So apologize if you chose yellow. I can't give you points. It's not my fault. Oh, it is my fault, but I'm gonna pretend it's not. All right, let me talk about this yellow sheet because this question's been asked to me before and it's a really good one. So how essentially I was asked, how did I get my unit conversions from the yellow sheet? Because it does not show the same values that I have. How does that, where am I getting my values from? And I do this in all my videos, all in class two, is I'm always using essentially my own version of the yellow sheet because I'm not a fan of the yellow sheet's conversions for small units. I think they're confusing in my opinion. I'll see you later. Thank you. But if you could go over question 5 and 14. Okay. All right, I'll try to put them at the end of the review for you. If worse comes to worse, you can always message me about it too later. If I forget, but I have it written down in case I don't. So, going back to the yellow sheet. So the way that the yellow sheet looks is it kind of has this written down. It has centimeters. It has 10 to the negative 2 next to it, as well. So what exactly do those values represent? What does that mean? Well, when we're kind of looking at those, and I wish I had the yellow sheet near me. I usually have like 30 of them laying around my office, and I don't. I guess I could pull one up. You know what? Let me find one so that way I can make sure I explain this. Actually, wait. Wait, hold on 1 second. I can share it. Give me a sec. It works for centimeters cubed to meters cubed, which is probably the most common one that you would ever have to use. Okay. So here's the yellow sheet. Sorry, it's not yellow. It's white for me, but this is the original version. Um, so when you're looking at this thing, we were using the following conversions. We were using Centi, and we were also, well, we'll just focus on that one. So let's say we're using Centi. So the way to read this thing to make sure you're using it correctly, if you don't want to use my version, you can use this one. The way that all these represent is the right-hand column. So everything that's over here, I'm highlighting in red real quick. This represents what the base unit value is. So I'm going to write below it, this is the base unit. And then what do I mean by the base unit? This could refer to it as grams, liters, Celsius, joules, any type of unit that can have a prefix in front of it. So the big ones that we've been using in class a lot are really grams, liters, and eventually we're gonna start using Kelvin and joules a lot more. So those are kind of the most common ones for now that I can think of off the top of my head. And so I guess there's seconds too, right? But there's no time conversions on this test. It's mainly what you kind of applying to lab is what I focus on. Um, so if we were to read this, everything that's on the left-hand side, these are all referred to as just being one of whatever that value is. So if you were to read this, it means that you have 1 centimeter for every 10 to the negative 2 grams, which is the opposite of how I describe it, right? The one way that I look at it, so if you were to write that as a fraction, I flip the fraction or I flip the numbers where I say that if I have 100 centimeters is 1 gram, which if I rewrite that, that's 10 to the 2 is what that's equivalent to, right? So I flip my numbers because it's a fraction trick. You can do that. And when you have a larger number, I find that students are less likely to make errors if they don't have to put decimals in their calculator. So it's one of the reasons why I personally use it. And if you don't believe me, one thing you can do is for yourself is if you grab a calculator and you do 1 divided by or 10 to the negative 2, and you tell me what answer comes out. So do this math conversion here, the one that's blinking right now. Put that in your calculator. What number do you get? So do 1 divided by 10 to the negative 2 and tell me what value you get. And you're gonna see why this this makes sense. Because it's a ratio. You get 100, which is the value that I use for centimeters. So 100 centimeters is 1 gram. It's a ratio. It could be as long as the ratio is the same, you can use whatever numbers you want realistically, as long as the ratio is 100 to 1, right? So what's on the bottom, it does show 100 to 1, but it's dividing by that value in this case. So it's just another way of looking at it. So if you want to use just your yellow sheet, then you would define your conversions like this. So just to show another one, like if you had 1 kilometer, that's equal to 10 to the 3 meters, being that's 10 to the 3 up here. Or if you had 1 nanometer, that would be 10 to the negative 9 meters. So you're just kind of defining based off that. So it's another way to do it. You can use that. You can choose whichever one you want. But I personally prefer to always use big numbers because I find that usually you guys do better. And then I always stick to what people do better with. I'm always going to do what helps my students. There's a reason why that I make you guys do all the things you do. It's because I found that it's made big impacts. So it's good things, right? Better grades or more happier students and more of you pass. So let's keep going. All right. So hopefully that answered your question there. All right, so going back to this guy over here, and like I said, if there's any other questions anyone has, yeah, and keep in mind for this question here, right, you won't have the white periodic table for those of you guys who have, oh, well, everybody probably has one at this point. Um, but if So your yellow one won't have the charge written. When you get it, you are welcome to brain dump whatever you want on that thing. I don't care. That's fine. But it has to be like in your head. Um, and there is always a periodic table in the lab too that you can always look at as well if it helps. The one on the wall. Don't forget that exists. If it helps. I don't know why it would help more, other than that it has the Roman numerals for valence electrons on it. So where I'm a little confused is how do you know it will convert to grams? Does that make sense? So are you talking about if you kind of like have, let's say you're doing a prefix conversion, how do you know if you need to go to grams first? Like that kind of question is what you're asking? Like how did I decide to go to grams and then go to the prefix? Because that's what I think you're asking, but I wanted to clarify. Okay, good. All right. It looks like almost everybody got this one, right? So it's on the second column. So that would be a 2 plus charge. Nice. Yeah, if it's the question I think you're asking. So when I go to grams or convert to the middle of the prefixes, I do it whenever I have to usually go from a prefix to a prefix. Being that the table, it's all in reference to the base unit. It doesn't give you the differences between prefixes. So what I mean is if you had to go from centi to micro, well, you can do the math and do that conversion, but what I see is most students are not comfortable or confident in their math skills to do that. So usually what I say is you go to take centi, you go to, let's say, whatever your base unit. So let's say is centimeters, you go to meters, and then you convert back to micrometers. It involves an extra step, but it allows you to use your reference sheet as like a crutch to get yourself through it. So that way you get the correct answer. Being that, it's no secret at this point. You have references all around you. Even when you're working and doing these things, you have computers, you have your phone, you have resources. Obviously, you got to be able to know how to use them correctly. That's the thing, is why you still have to take classes and can't just have AI doing it for you, because that's how someone's going to get killed one day. It's, you gotta have the brain power to be able to recognize those things, is what I always say, is you got to be able to critically think through it. So the way I critically think through it is I go to that base unit because I can use my reference sheet, and then I go back out to whatever unit. Um, so that's how you know when it's whenever it's going to be, I think from prefix to prefix is how I know to, I think is how, when I go to the middle step. But you don't have to. You could just skip it. But most students I see need it. Probably I would say 85% of people need it. Identify the element that is a should say metal, not mental, non-metal gas, and has a symbol that starts with the letter A. So what that means is you got to know how to kind of use your periodic table so that way you know where the different areas are. Um, and kind of know how it's sort of organized here. If you're not sure how to do this one, what's vital is, so you should be able to see the answers on your device. So let me share my tablet so I can share is there a trick to memorizing the elements in the periodic table? You don't have to memorize all of them. I always tell students, I think it's wise to or to memorize the first 20. And the reason I say that is because it's for all the nursing people mainly. Most of those first 20 elements are your essential minerals. So I think like 11 of the 20 are your essential minerals. So like potassium, sodium, magnesium, all these things that, are vital to your health. So when you have to take nutrition, knowing about those essential minerals is helpful. So in order to memorize them, really for me, what was my trick is I just put the name on one side and then the symbol on the other. You can put the atomic number if you want on there, but and then I guess that helps, I would say. But you don't need to memorize the mass. Like you always get the periodic table for that. But I would think that the name and the symbol are I would say are good starts if the atomic number is, it's not bad to know it, but you could get away with not knowing that. It just kind of depends on you. But I think flashcards, that's what I would do. You get 100 pack of flashcards at the dollar store or at the bookstore. I think at the bookstore they're like $2, I think, or something like that. And that's usually what I did. Or if you're someone that's like, oh, I don't want to buy flashcards, you probably can Google like periodic table flashcards, and I guarantee you there's probably something. I wouldn't be surprised if I put periodic table flashcards at some point in one of the modules at this point. Um, being that I always am putting different study references in places. All right, so how to do this one? Looks like almost everybody got it, which is fantastic. So what do you do? So the first thing is for you guys, the zigzag is not in red, it's black. So that zigzag line, what that represents, it's the boundary between non-metals and metals, right? So non-metals is on the right, metals is on the left. Now, the more right you get on the periodic table, the more likely you're going to find a gas. So the one thing area you definitely know are gases, right? The noble gases are all gases, right? So that's kind of the area for certain are all gases. After that, it's like these guys here, the halogens are typically gases. The one that's kind of hit or miss is bromine. That's usually a liquid. It just depends on the temperature. But the noble gases, it's in their name, right? So knowing those names, when we've done so much electron configuration, right? So hopefully that kind of rings home. So if you're looking at that, right, you can see which noble gas has A in its name, and that would be argon. So I would hope that that's the choice. Yeah, it is. Okay, good. I was like, oh God, hopefully I didn't lead you guys on a tangent without checking the answer, and it's fun. Um, okay, and then I got to ask the question. I'm having trouble trying to decipher whether we should use sig fig, scientific notation, or write the full decimal number for our answers. Will the exam problems let us know which we should use? That's a loaded question. Much more loaded than you realize it is. My answer usually always is you want to round it to the correct sig figs, is usually the answer I'll always stick by. When it comes to when do you need to know if it's scientific notation, it usually is whenever it's a very, very large number or a very, very small number. Or let's say you are rounding the value and you could not illustrate the correct number of sig figs with your rounded value. So what do I mean by that? So one of you in lab today had to round. It was like something kind of like this. It might have been actually it might have been Melanie. It might have been her number. She had like this number, which was 10,049 joules, and she had around it to two sig figs. Well, how can you actually go and try to round that? Well, two sig figs means that you got to round it to this spot. So what's the issue here is, well, okay, well, I can round that, not a problem. But when you do that, right, four is you round down. So it's going to be 1,000 is going to be your answer. That's not wrong, but the thing is, you're not illustrating the sig figs correctly. So you're actually losing sig figs because this one only shows one sig fig. You need two. So the only way to show that correctly is using scientific notation. Because when you put this in scientific notation, so we say 1, 2, 3. So when I say 1.0 times 10 to the 3, now I'm telling people that this zero is significant, but it was rounded, so I couldn't actually, illustrate that with the original number. So it's always based on, it's kind of your judgment a lot of the times. It always should be rounded to the correct sig figs. There are some homework questions that do tell you to do the full decimal value, and then in the next question it'll tell you to round it. But you always want to round. The only time you usually don't round right away is, let's say, if you're doing lab calculations, you might put your whole decimal value, and then at the very, very end, when you're finished your calculation, then you round at the end. So you want to wait until like the very last step. It's like what we said with multiple step operations. Wait till the end to round. If hopefully I answered it. Okay, and then Audrey asked, can we go over how to know what ions are in a random compound and its chemical formula. Example, aluminum dichromate. Oh, you're welcome. Or in a random compound and its chemical formula. Oh, so you're asking like, are you asking like how to
I'm asking
know?
about like
Oh,
the
go.
rolling compound. Sorry.
Are you okay? I was like, oh my God, a voice. It scared the heck out of me. Go ahead.
It was
Say it
okay. I just
again.
want to keep typing.
No, you're good. What was your, say it again.
Um, it's like the rolling compound homework we have. At the end, you have a start with
Oh,
like
yeah.
the word and then like find out what the cation formula is
Okay.
and the anion
I
formula.
got you. I forgot about. That's what you were referring to. Okay, that's perfect. Thank you for telling me which assignment. Right. So that one, so you were saying aluminum dichromate. So that's a great example to use. So this one kind of comes with I guess a few things. It's knowing your how to use your reference material and a little bit of some memorization too, I guess. Because, for example, what I mean by memorization is like knowing aluminum's charge, for example, knowing the cation on that. Just because that's part of the steps, you kind of got to know that charge. I mean, it's on the third column, so you can kind of know it, but you know. Dichromate is one of your polyatomics, so knowing that one too relies on using the green sheet. Um, on the exam, in terms of knowing names, I believe I think there's only one. I'm pretty sure it's just one. Maybe there's two, but I think it's one. And it's not a, if it is the polyatomic one, like I said, it's going to be an oxyanion. It's not going to be like dichromate, which is one of those bottom ones. That's a little harder. So when you're going through this, just to kind of talk about it. So the first thing you want to do is you had to identify the cation and the anion. So cation is always written first, anion's always written second, always, no matter what. So aluminum, right, has a 3 plus charge, right? So it's always that charge no matter what. Afterwards, you got to define what chromate's charge is, right? So that's when you got to use your reference material. Whenever you don't see it in, that's one of the reasons I say like you maybe watch the T43 video so that way you can know your 8 polyatomics because it helps limit your search. That's the big idea. When you have all these reference materials, it is so overwhelming the amount of information you've been given over the last 5 weeks. At least I think so. If you guys don't agree, then God, you're amazing. But most people think that, right? It's a lot, and that's okay. But if you start memorizing portions, it eliminates a good chunk of your search. That's why I say memorize the first 20 elements. Know the T43 method or whatever to memorize that top part of the polyatomics. So that way it's one less thing to look at. So dichromate's at the very bottom of the green sheet. Hopefully I'm getting this one right. I think it's C2O7 and it's a 2 minus charge? Is it 2 minus? I don't have my green sheet in front of me. Anyone confirm that as it's 2 minus? I don't use dichromate a lot for examples. Does anyone know what charge it is? I know it's C2O7 though. At least I'm pretty sure, unless I'm wrong. Ooh. It's a 2 minus. Yes, got it right. Yeah, I know things. All right. So C2O7. So and being that there's a couple of people, so I'm gonna log off. Thank you so much for the help. Oh, absolutely. You're absolutely welcome. Hopefully it helps. I actually need to go. I'm gonna watch the recording tomorrow. Yes, my goal is to try to edit it down so that way it's not as long. And then I'll probably upload it to YouTube so that way any of you can watch it whenever you want. Um, and then it's, just available throughout the whole semester. So you have it for the final if you want to rewatch any of it. Um, so as long as it's recorded properly, if it has your names and stuff in it, then I won't use it. But I think I simulated it so it doesn't show any of them. I hope. We'll see. Worst because we're supposed to post a Zoom link. Okay. But going back to that. So we gotta swap drop it next. So we have the cation anion, we have them labeled. Now you gotta swap drop. So we have our 3 that's gonna go outside the parentheses. So that's gonna come down to the left, and then the 2 is gonna come over next to aluminum and we will write that as well. And when we rewrite that, we'll have Al2, C2O7 with a 3 next to it. And let me clean up that 3 because that is bad. Okay, there we go. Oh, I'm frozen? Uh-oh, never mind. Okay, less frozen. Okay. It's like maybe my internet connection. I'm sure it's not the best. But that's kind of how you go through it step by step. So define your ions. And then so let's kind of write that down. So define ions. And that might require a mixture of periodic table. And then let's say if you don't know the metal charge, then it's going to rely on you finding the polyatomic, which is always going to have the same charge. So you got the like we were doing in class for Monday, Wednesday, like we were just practicing all the polyatomics, all the predictable stuff with those variable charges. So sometimes you gotta make sure you know where to find them. So the more you practice it, the easier it's going to be to find them. That's why I started doing that nomenclature game I'd say last spring or fall. I started doing it, and it's been a lot of your naming and swap drop has gotten so much better since I started doing that. Most of you don't really struggle with swap drop after that. So that's the more important thing. Naming is important too, but it's the swap drop that's crucial for when we do chemical formulas and how to do balancing. And when we do moles next week, or for, well, Saturday's doing moles this week, but Monday, Wednesday, when we do moles next week, it makes a big difference. Okay, so hopefully that answered your question. For the parentheses, when do we not use them? Great question. So when do you not use them and when do you? So you use them only for polyatomics and only if you had to swap drop a subscript next to it. So in this example, I had to bring the 3 to say that I have 3 dichromate ions. The whole dichromate is a unit, right? That whole polyatomic is one whole thing that's connected. So when you have to swap drop, so if you had a swap drop and it's a 1, let's say you were bringing down, so trying to let's maybe come up with an example like that. Um, let's say I had sodium uh carbonate, for example. So when I were to do this one, right? Carbonate's a 2 minus, sodium is a plus. So when I swap drop those values, right, and I bring them down to each side, so I bring the 2 down to sodium, I bring the 1 down to carbonate. What is that going to make? Well, we'll have sodium 2, CO3, and then we'll have a 1 next to it. But remember, 1 is not needed. One of the things I like to say is chemists are lazy. If we don't have to write it, we shouldn't write it. So in that case, being that it's 1, you don't have to include the parentheses. So we get rid of them. It's only when you had a swap drop a value next to it. So if you include them though by accident on any of the homeworks, it will mark you incorrect though because you don't need them. It's only when you have a subscript. So if you're like, why am I getting this wrong? I have the polyatomics, I swap dropped it, I did everything right. It might be because you include the split parentheses. And you can always send me a screenshot too on Discord or, Discord's always the easiest thing. But if you send it to me on there, then I can just be like, I'll tell you in 5 seconds if that's the issue. Usually that's it. Or maybe you forgot to reduce the subscripts as well. That's a big one too. A lot of people have been doing that too. Yeah, that'll be MGF2. Yep. So for those ones, you don't need any parentheses. So atoms, you don't need them. It's only for polyatomics. So MGF2, perfect. So you just got to make sure you put it as a subscript when you type it into MyOpenMath. Which of the following is a pure substance? All right, so this was one of the things I was asked about on homework number 4, question 5. Was like how to discuss if it's pure substance, is it a mixture, all these kinds of things. So, pure substance means that it's only one element or it's one compound. So, thinking about that, right? So, you guys mainly picked between air and ice. Air is a mixture of elements, right? It's a mixture of the diatomic elements. So, it's nitrogen gas, oxygen gas. You can argue that there's other contaminants in there too, obviously, but it's mainly nitrogen and oxygen for the most part. So that's what we consider a mixture of diatomic elements. Um, in terms of ice, it's just water. It's just frozen water. So it's compounds. So it's a pure compound. Hopefully it's a pure compound. Brass is a mixture of metals, so it's like I'm gonna say copper, iron, and a couple other things together, maybe some zinc, all mixed together, and kind of doing things. You're also done with the mini lectures too, because you got added a little late, so you got a little extra to do. Actually, you got to catch up. That's hard. And then seawater is salts, water, and those mixed together, and all that stuff. Okay, I was asked the question, will the exam tell us when to reduce the polyatomic, or should we automatically do it? Do you mean like in terms of reducing like the subscripts? Like let's say if it was I don't know, you swap dropped and it had like atom one had like a two and then atom and then polyatomic two had a two outside and you reduce them. You should automatically always reduce if you can. So it's whenever they're commonly can be divided by the same number, but make sure you never touch the polyatomic itself. As one of the phrases I say a lot with that one, a polyatomic is like family. They stay together. You don't change the family. So like carbonate, it's always CO3, nitrate's always NO3. Don't change that. Only the subscript outside the parentheses. That you can reduce that. And it's if it's like 2 and 2, reduce it. 2 and 4, reduce it. If it's 4 and 8, anything that you can see that it can be divided by a common thing. So, this was a question on your homework. It goes over like Beano's asked about mixtures, elements, compounds. What do you got to do? So this is kind of one of them. All right, hang on. Oh, you're absolutely welcome. Oh yeah, and you can, and if you want to do the Kahoot too on your own, it is posted in the exam module, just so you guys know. So it is available. So what you're doing for these is you're kind of like looking at each thing that's given to you, and you're trying to see is well, exactly is it showing? So for this one, right, you have sodium hypochlorite is what's being shown to you. So NaClO. So you see three elements that are bound together, and it's the only compound that's being listed here. So you can make the assumption that it's just one compound that's being shown. So being that's the case, that means that this is considered to be a pure compound. Same with like the next one. It's also just like one compound. You can do the same thing. The ones that are harder are these guys, depending on which pictures you get. So you're looking at those images that like we've seen before that have gone through any of the videos or in person. Before I had them with just black and white balls on at least in my videos and stuff. But these are you're looking at, okay, so we have these two blue orbs that are connected to each other. So it's a diatomic. It's the same element that's connected together. So this is referring to a diatomic. So something like nitrogen, maybe it would be a good guess, like N2. So what is that? Well, it's not a mixture of multiple elements because you would need two different gases, right? Like maybe a red ones and blue ones or red and yellow, something like that. So this again is a pure element, even though they're bound together, but it's just one element because this is the natural form that the diatomics exist in. One of the things I say for remember your diatomics, have no fear of ice cold beer. And this is one of your diatomics. So in that case, this one's kind of the same idea. It looks like it's the same ones, but it's just a solid versus a gas. This one we didn't really get a super good question. Wonder if I could make it give me a different one. I guess I can on my version unless I submit it. But it's there are other ones that do have like different compounds here that are all mixed together, so you'll see multiple different things. Are there any questions with pictures on the team assessment? There's some on the test. I'm gonna say I don't think I put any on the test. On the team assessment, yes, because you have your notes. So I thought that'd be a little bit more manageable. And you can talk with your partner about it too. So I try to do like more thought-provoking things with your partner so that way you have someone to also stress with together and it's less crazy. But like I said, the team assessment, don't stress over it. One of the things too is like don't worry about your grade until I see them, because usually the grades are really low at first because like the auto grader doesn't grade them well. So I gotta like look through all your grades. So whatever grade you get on the team part, don't freak out. This you gotta give me time to look at them. So that's another thing to warn everybody, especially Saturday, because you guys I don't see. So I'm like, I don't need you guys to accidentally kill Professor Gilly, because your grades are like it says like a 60%. It's like that's not the real thing. I got to look at it. It's probably like an 85 or 100. I just got to look. So just so you know for that part. Oh, and then density. Yeah, we can talk about density. It's gonna be one of the questions on the Kahoot though. So I hopefully it comes up soon. So you want to go through your process, Um, one of the things that's never a bad study tip, it kind of involves a little bit of work, but you could always kind of like define your own little uh like how-to guide for anything. You don't have to, you always use mine. It's what works for you. Does someone have a question? I heard a unmute and I'm scared. I was like, am I gonna get scared again by a voice coming from like, oh, talking. But all right, so it looks like we kind of had some people who picked a couple different things. So let's show it real quick. So with this one, so you want to look up the two charges. So the first thing is like if you were to look up aluminum, right? It's one of your steps. So in this case, it would be a 3+ charge with that one. So tablet slowly coming up. There it goes. So you'd have aluminum, right? That's 3+. It's a part of your steps, as I kind of always say, right? So just kind of remind people, what am I talking about? So when it comes to the periodic table, there's like naturally steps in the periodic table that look like this. So it's aluminum, zinc, silver. And then they have the charges +1, +2, +3. So it's first step, second step, third step. I just think it's helpful to remember it. So we got Al, and you guys probably know oxygen, right? That's a 2- charge. And now what you're going to do is you're going to swap your numbers, right? So the 2 is going to come down next to aluminum, and then the 3 is going to come down next to oxygen. And then what you will get is you'll have Al2, and then you're going to get oxygen with A3 next to it. Okay. So it's just kind of showing that those numbers come down. Aluminum still has a 3+ charge. So just keep that in mind. It's just so that way the overall ionic compound is neutral, is the whole idea. So to kind of like show that math, right? If you have two aluminums, right? They're 3+ and 3+. And then on the right-hand side, we have 3 oxygens that are 2-, 2-, 2-. You see that they're each 6 on each side. So it balances out and makes a neutral compound, which is the goal. It's lower energy, it's more relaxed, it's more stable. It's an easy one, right? So your atomic number is what you're looking at here for protons. There's probably going to be a question that has to do with atomic number. So knowing that. Maybe calculating the subatomic particles could be another thing too. Make sure you're okay with doing protons, neutrons, and electrons. This could be another one too, right? So it's a xenon is a member of which family, which means which column. So what's the name of that column? We said it earlier too. So I would recommend knowing the 2 columns on the left side of the periodic table and then the 2 on the right. Those are usually the most common. And then knowing transition metals, like just remember those names. So like where lithium and sodium are, that's the alkali metals. Where beryllium is, that's the alkaline metals. And then where fluorine is halogens, and then the noble gases for helium and down. All right, the number of dots representing valence electrons in the electron dot structure of nitrogen is what? Electron dot is the same thing as the Lewis dot structures, by the way, just so everybody knows that. Wait, I just realized it doesn't even give you the numbers for how many dots. Okay, so feel free to type in the chat how many dots you would have around nitrogen. The choices do not match this problem, so feel free to pick whatever answer you want on this one, because I actually have no idea which one's the correct. None of them make sense, so just pick one. It must not have saved my choices because I was just like copying a previous problem each time and then editing the values. So, but try to figure out how many dots there are though. Still, we'll go over it. Okay, so kind of how to do this. So for any of these, so the biggest thing that's important here is this is about valence electrons more than anything. And Audrey, perfect. That's a perfect answer. And same with Jocelyn too. Perfect. Um, so valence electrons, I can guarantee you'll have to count them on the test somewhere. So what do you got to do? It's pretty easy once you realize the trick behind it. So the first thing you always do is you want to find wherever the element that you're looking for is, right? So we have nitrogen right here. And what we do is after that is we can if we count how many S and P electrons. Oh my God, I'm trying to erase this thing. I hate that they changed that. How many S and P electrons there are in its, I guess, its highest quantum number, its lowest row, if that's how you want to look at it. So if you remember, we could number each row, right? We have 1, 2, 3, 4, 5, 6, and 7. So we're in row 2. So we're going to count all of the S and P electrons until we get to nitrogen. So S is the first two columns, right? So we have 1, we have 2, then we have 3, then we have 4, and then when we get to nitrogen, that's 5. So that tells you have 5 valence electrons, aka you have 5 dots when you show the lowest dot structure. So all we're going to do is we're going to go 1, 2, 3, 4, 5. And it doesn't matter where the 2 dots are, if you have on the left, the top, the right. As long as you have 5 dots and one of them is a pair, then you got it perfect, right? Which is the whole idea. Usually I always start on the top and then wrap around when I'm doing it personally, but you can, if you start on the left or right, it doesn't matter. I always get asked that at some point from here until then. Good job guessing calcium on that question, by the way, for the random guess. I don't know how that's correct, but none of them are correct. So good job, whoever's yellow, or whoever got the yellow choice. Okay, so we got this one. An atom containing 7 protons, 8 neutrons, 7 electrons is what? How would you define it out of all these choices? And just like as a thing too, make sure you're not trying to match the atomic mass for an isotope to the one on your periodic table. So this is for very specific isotopes. So use the data that's given to you. The only thing you can look up realistically is what the elemental symbol is if you were to try to write out the notation. So always use what's given to you in the problem. So if we were to try to write this guy out, the biggest thing is that the only one that was true here was that it was neutral. But I don't think this is a bad time to go over making sure you guys are okay with writing that atomic notation, right? So when we're kind of doing this one, you had 7 protons. So that's going to be nitrogen again. So what we would end up writing is nitrogen 7 at the bottom for its number. And then we had 8 neutrons. So it's 8 plus 7 for the mass. So it's nitrogen 15 would be the value. And you notice that doesn't match your periodic table. It's just a different isotope of it. Remember, these are averages of all the isotopes available for these species. So, don't automatically assume like it cannot exist or something. And for it to be an ion, the electrons would have to be different than the
Right.
protons. Perfect typo. What is the electron configuration of aluminum? So these ones are like really tricky multiple choice. This is one that I actually took from an old final exam. So with the final, when we get there, right, it's a standardized test. So it's like a studying for, the basics. So you're kind of looking at a mixture of things. So you want to, one, see if you can write it out for aluminum. That's usually what I recommend doing first. I usually don't just look at the choices. I always try to answer the problem without looking at the multiple choice. The only time I look at the multiple choice is if I have no idea on how to do it. Um, because you want to see if you get your answer first and then you check against what's there. Um, the other thing you're kind of noticing with these is you need to pay attention to like anything that doesn't follow the rules of electron configuration, which, okay, everybody got this one. So here are pros. I don't even have to even explain it. So you always want to make sure that you check if there's anything that violates rules. So what I mean by that is like, I think if you look closely, like you see like C is 3p8, for example, like you can't have more than 6 electrons in that one. I think there's like another one. I thought that was Wrong. Maybe not. It's all the same, same. Oh, I guess it only changes the 3p. So you're kind of like looking at every orbital sometimes to make sure there's nothing like weird happening, like nothing in the wrong orders, no electrons missing. Like, are any of the rules being violated? That's one thing you want to check too. All right, double points. The number of electrons in the outer energy level of a neutral atom of boron is what? And I guess this one you could argue is a Bohr model example, if you want to, but you don't have to define it that way. If you know your vocabulary, then you know what this is referring to. It's just wording it in a scary sounding way. We did this problem kind of already, but with dots. We did with nitrogen. So with this one, what is it referring to? So it's talking about the outermost energy level. So that's talking about the valence electrons. That's all it's asking you. It's just kind of in a scary worded way. So one of the things I always tell students is whenever you have word problems, like and this one wasn't that long of a word problem, but always try to see if you can find the most important piece of information. So like for this one, it says boron and then outer energy level. So knowing valence is always talking about the outer level. So what's on that outside is the key here. So when you're doing that, right, you count your S and P in that second row for boron. So it's going to be 3, right? Is the whole idea. So you count lithium, beryllium, and then boron, and that's how you get 3. There's 5 electrons, but it has 3 valence electrons. So 3 valence, 2 core electrons. That's how to label them. All right, which one is for carbon? What's the correct way to write it for the electron dot structure? And like I said, this was an old exam, so if you feel like you've been doing well in this so far, then then so far you've done at least the basics and the beginning stuff so far, which is good. Like I said, it's just your fundamentals. This is probably around the same difficulty as the current one. If I were to kind of label it, I think maybe there might be. We haven't gone over the last 10, so it might be same level difficulty for the last ones too. And if you haven't known them, then write down the topics, and that's so now you know what to study. That's the idea. Never let it scare you. It's just okay, now it's time to make a plan and decide what you need to do. If it is something you're like, oh man, I don't know any of this, then okay, time to study. But you guys have been doing well in these things. So yep, you got it. So with this one, how do you do it? So it's same thing, another valence electron one. The reason why it's very valence electron heavy is because this is going to be one of the concepts we're going to use for covalent bonding, and we have to be able to draw the structures, which we're going to be doing on chapter 6. So right now we're on chapter 5 for everybody, so it's going to be soon. Next couple of weeks we'll do a lab with it where you're going to be putting all these together and showing how they share electrons, which involves the Lewis dot structures. So big thing is when you're doing these, right, is you write the elemental symbol and you put a dot on each side of the atom like it's in a box, right? So you see with C, there was 4 dots, one on each side, and then if you need a 5th or 6th or 7th, you then start doubling up. So each electron's like lonely. It's kind of like Hund's rule, where every one of them's by themselves first. How do you start doubling up? Oh, so that's when you get to that 5th electron, that's when you start pairing them. So kind of imagine that there's like, well, because there kind of are 4 orbitals is what it's representing. It's representing S and P. So that's like why there's only 4 sides. Because there's 3 p orbitals and 1 s orbital. So the first thing is when you're looking at it is look at your conversions. So you had 0.125 grams of ampicillin, and then it had said there's 250 milligrams in a 5 milliliter shot essentially. Um, so you have 2 types of terms. You have a term that's by itself and then a fraction. You always start with the term that's by itself. You never start with a conversion term unless you have no choice. So when we do that, the term that's by itself is the grams, right? You can't flip that value. We have grams that's on top. You can't change it. So it's something that you can use as your starting point. So after that, well, we want to be able to bridge it to milliliters. Well, how do we get there? Well, what's the common factor between these two things? Well, I see I have grams and I have grams or milligrams in the conversion. So how do I go from grams to milligrams? Well, that's when you got to look up your unit conversions. So the first thing you got to ask yourself is, well, how many milligrams are in a gram? Well, when you, oops, that's a highlighter. When you do that, right, you quickly see, right, 1 gram is 1,000 milligrams. We'll fill that in. And then we can cancel our values. And if you're wondering where I got 1,000, right, it's the same thing as 10 to the minus 3 grams is equal to 1 milligram. So you could also use that too. Grams cancels. And then we have our milligrams, which we can then cancel with our last conversion term, which is 250 milligrams is equivalent to 5 milliliters. And then we just cancel our units. We're letting the units guide us. We see that they're canceling. It's getting to our goal. And then we have milliliters as our final unit. Okay. I don't know why I keep picking highlighter. All right. So then what we would do is we multiply, right? 0.125 times 1,000 times 5. And then we'll take that value and then divide it by 250. And what we should end up getting, I guess, would be the answer, which was C, which is 2.5 milliliters when you do the math for that. Okay. And the reason it's 2 sig figs is because the conversion term on the right over here is 2 sig figs. And these are 3 sig figs over here. Okay. So that would be your final answer. So this is a two-step one. This is like probably, this is a kind of dimensional analysis that it could be. I tend to do drug-related ones just because most you're in the health sciences and it's a pretty common thing that you have to calculate dosages and anything that requires medicine, especially when you get into the actual programs. It's usually one of the exam steps that they have, and it's one of those things that you got to get like I think they say you got to get 100% on it. They don't let you move on to the next step. So measuring out your how much prescriptions and knowing all that's really important because you don't want to accidentally overdose a patient or underdose a patient too. So how would you find the average atomic mass for this compound? So it's like what you did with the bead lab. It's the exact same thing with isotopes. This would probably be like arguably one of the hardest math problems you could have, just because I don't know, it's just a long one. They're not crazy hard to do. It's just long. It's a lot of plugging in values, and okay, looks like the three people that were able to get it did get it, which is really good to see. Um, there are a couple tricks to this one, believe it or not. So, and a lot of times with the multiple choice, you are able to eliminate answers. Um, so when it comes to the averages, what does that mean is that your smallest value is 22.17. Your largest value is 24.19. So it has to be in between them, right? So what does that mean is you can eliminate B and C right off the bat. There's no possible way for that to be between your masses. So it has to be A or D. Now, the thing is, you actually probably you might be able to get the answer without even doing the math here if you use reasoning, because notice how the first two are 90%. That's the biggest weight of this. So that tells you that the value has to be probably between 22.17 and 23.18, which kind of really only fits really D. It's the only one that's in between them. So you can actually, there's a way to reason through this without doing a single thing of math, which is something you can kind of always, if you understand percents, so like where would it be weighted? It's like a trick if you're running out of time. Let's say you have like 5 minutes left, you haven't done 6 questions, pick the answer that's closest to the highest weighted percentages. It you'd probably have a very good chance of getting it correct if you had to take a blind guess. And some of you maybe you did guess, I don't know. But if you did, then you already did that. But if you were to do the math though, so it's a pretty easy calculation to do. The hardest part is remembering that you cannot use the percents in their percent form. You have to convert them to decimals, and that's usually the thing that most students forget. So what you kind of do is, so this was kind of like the lab with the red, the black, and the white beads. It's the same idea. So what you do is you multiply each of these sets of values. So like for the first set, you multiply them together. For the second set, you'll multiply them together. And then for the third set, you'll do the same thing, and you're going to add those together. So kind of setting that up, what do I mean by that? So we would take 22.1760. We would multiply that times the decimal of it, which is 0.45. So that's this value here that's converted to decimal form. Then, like I mentioned, we're going to add that to the next one. So you take your mass again, 23.1847, multiply that times the 0.45 again, because it's the other percent. And then you're going to add that again to the next one, which was 24.1934 times 10% this time. Okay. And I'm not too worried about the sig figs because we're pretending it's like a test. You're just going to write down your numbers. You don't need to include every single zero in your work, right? So once you do that, you'll go through your math, and what you should get is about 22.83 for your number. And you got like 22.831655, and then just round it to 4 sig figs. And we'll see that that matches D in this case. Okay. So that's how you kind of do a problem like that. It's a little bit tougher, but it's so that's probably as hard as it could get. At least I think. I think that's the toughest one. Or the order dimensional analysis. I think that one's tough too. It just kind of depends on which one you're not as strong with. All right. Based on the compound MgCl2, what is the charge of Mg? So with this one, it's kind of the same idea that you could do it two ways. One is magnesium's charge is always the same thing, no matter what. It's always 2 plus. So you could go through and you could also do the reverse swap drop if you want as well. You got to be careful doing the reverse swap drop because if it was reduced, you could get the incorrect answer. I always kind of recommend going off of your predictable charges for these. So like with MgCl2, right? The charge for chlorine is always -1. There's two of them, so you know that the other charge has to be 2 plus. You could look it up on the periodic table as well. So magnesium is always going to do that exact trick. Now, what I mentioned with the reversible swap drop is you can take those values and bring them back up here, but if it was reduced, it will not be correct. So it's kind of good to know at least one of the ions to make sure you're doing that correctly. I only do it usually on binary species and maybe polyatomics, but I usually don't do it for variable transition metals. Usually that's when a mistake will happen, just because it could be all kinds of numbers. Okay, so finally, density question. It's like Catherine's been asking about that, I think, for like 2 hours. Finally. All right, uh, all right, some gold has a mass of 521 grams. It is added to 50 milliliters of water. The water level rises to a volume of 77 milliliters. What is the density? That is what it's asking. So this was what you did in lab, right? So it's the displacement method. So you got to kind of try to remember that thought process because density is a really important conversion. This is also like a very, very common lab practical question too. It's pretty normal that I've seen it several semesters. So when it comes to the lab practical, I have a review video for that one too. But there's usually it's different every semester, but this is a pretty common one the professors pick because we come together and choose how to make the practical to standardize the 20 some sections of Chem 3A. And this is usually it's something like that. We're not gonna give you 500 grams of gold, but it's usually done with like aluminum or something. But it's a pretty, common thing that you might have to do in 5 minutes. Um, so when we're doing this, it kind of it's a few things, right? It's remembering what density is, which is the first one, right? So density is mass divided by volume. Now, the thing is, one of the most common mistakes that students do with this one, which is maybe what you guys did, is they take the mass and then they automatically divide it by the largest or the largest or the final volume is what I should say. And that's not the case, right? So the way you want to do is you want to make sure you've got to calculate what the volume of the object is, not just use the volume of the water. So what do you mean by the volume of the object? Well, that's the equivalent of delta V, or you can, if you want, you can define it as volume of object if you want. But delta is usually what we commonly use in a lot of applications with final minus initial. So what we do is we take 77 milliliters, subtract it from 50 milliliters, and this would give us our volume of our object because that's what we dropped into the liquid. So we have 27 milliliters. Now what we'll do is with that, we'll plug that into our formula. So we had 521 grams, and then we're going to divide that by our 27 milliliters. And what we should get is 19.3 grams per milliliter. Okay. Now, what other density questions could you be asked too? You could be given a density and you could be asked like, well, what's the volume of this or what's the mass of this? So let's say if let's say our gold was oh, can't see. Oh man, damn it. I didn't realize that. Shoot. Darn it. Okay, let me bring it up. Thanks. Thanks for telling me. All right, so I ran it over with this. So the first thing I did, right, just to kind of point it out real quick, is I wrote down delta V. I subtracted my volumes. So it's 77 milliliters, subtract from 50. So it's final minus initial is where those are coming from. When that happens, right, that's your volume of your object. So that's where I got the 27 from. Being that we only care about the gold rock, we don't care about the liquid. We just want to know what our volume of our object is. So once we have that, we'll plug that into our density formula, right? Density is equal to mass divided by volume. That's something you have to know. I'm that you have to know density is mass divided by volume. So remember that because we did a whole lab on it, and it's something that it's a conversion that's in like all the homeworks, like all over the place. Mass divided by volume, right? So 521 grams is what our mass was. And then we're going to divide that by the 27 milliliters. When we do that, we get the 19.3 grams per milliliter, which is the answer. So the other way you could do this, a problem could be done with density is if it's used as a conversion factor. So if I were to add, let's say I found out that I found a 40 milliliter uh, volume of gold, and that's what I had. And I wanted to know how much it weighed. And let's say I didn't have a balance available. Well, you could use density to calculate what that mass is. So being that we have that 19.3 as our density, that's equivalent to 1 milliliter. So you could set this up as a conversion factor, which is something to keep in mind. It can be used as a conversion term, um, which it's kind of this most powerful part of its technique is that it allows you to bridge between volume and mass, which is one of the few things that allows us to do that. Okay. There might be a problem like this though, like something like this versus me like making up some numbers. Um, that might be. I can't remember if they're in here or not. I can't remember if I took it out or if I left it. All right, but we're almost done. So let's try to finish it up. So I'm also like, it's also really late. And I'm starting to lose my voice from the day. All right. So if we were to name this, so let's try to name this real quick. I know one of you are still trying to figure it out, but I'm gonna just kind of lock it in for the time's sake. So let's see how you guys did. So you guys are split between, those are the two I was thinking you'd be split between. So when do you use the Roman numeral? So this is something I've been talking about a lot today with Monday, Wednesday group. You only use the Roman numeral when it is not a predictable metal and when it is a transition metal. So it has to be in the D block and then it has to be predictable. So the only ones you don't do it for are aluminum, zinc, and silver. Those ones you exclude the Roman numeral because you know their charges, right? Aluminum's 3, zinc is 2, silver's 1. So they're known. It has to be one of the variable ones that you don't know it. I'm happy that you do know the charge though, which is aluminum 3. But it would just be aluminum in this case because it's known. It's a known value. Okay, what is the formula for copper 1 sulfide? Yeah, you could say D block. So it's the transition metals, but yeah, anything they're in the D block. Yep, that's when you use the Roman numerals. So for this one, you do know two things. You know what the charge of copper is. It's being told to you. And then sulfur, you can look it up for sulfur. So copper has a +1 charge. Remember, the Roman numeral tells you the charge, not the subscript. Sulfur has a -2 charge. So sulfide means sulfur. So how many coppers would you have to balance that? Well, you would need 2 coppers to make that a reality. So you should have Cu2S should be the formula. Oh boy, should be the formula for that one. So why not CuS? Well, it's because sulfur's charge is 2 minus, so it needs to be balanced. Remember, the Roman numeral does not show the subscript when you're looking at these. So being that everybody got this wrong, we should talk about it. So let me share this guy. So what this tells us is copper has a +1 charge. Sulfur always has the exact same charge no matter what. So in this case, it has a 2 minus charge, right? When we look that up on our periodic table, it's on the 2 minus column. So what we'll do is we drop those values. The 2 is going to come down, and then the 1's going to come over here. And what we are going to have is Cu2S as our answer. Okay. So we got to make sure we swap drop it. So like one of the big things I could ask you too is if I ask you like what is the charge of the cation in this case? Like so if I were to ask that, right, the cation always refers to the metal. So in this case it'd be 1 plus. If I ask you what the charge of the anion, that would be 2 minus, right? So you could have those are some other questions you could have too. Like there's some of this like some of the basics as well. So which one of these represents the correct Lewis dot structure for a bromide ion? I see that one of you has a question too. I think that, oh, I can get that about that big, as big as I can go. What's the charge for column 2 to the left of sulfur? So you mean 2 more? So like where carbon is, you mean? Or or do you mean like where beryllium is? So carbon, we usually don't say it has a charge. On the white periodic table, this is one thing I've been tempted to edit from it because on there I have +4 and -4. Those are representing another thing that we'll talk about later in the semester called oxidation numbers. It's similar to charges, but not quite the same thing. So the carbon column usually does not get ionized, so they usually do not have charges. These are the species that do covalent bonding, which is sharing electrons. So you'll see them more in next week or two when we talk about covalent more. So yeah, the only ones you'll see is when they're involved with polyatomics. Okay, this one we were split between 2 of them. So teal was correct. Oh no, 3 of them. So why not? So what do we have? We had one person picked D and then 2 people picked C. So C, so we got to read this one carefully. So it says the bromide ion, right? So when it says that "ide" ending, it's referring to the ion, meaning that it has 1 extra electron for bromine. So that whole column has one extra. So that means we're going to have one more dot than normal. So when we're kind of drawing that, the way to kind of go through it to show your work and how to do this on your homework, for this one too, when you're drawing these, and it's switching over, the first thing I do is I will write down my 7 dots for bromine, so the valence for bromine. So I got 1, 2, 3, 4, 5, 6, 7. But being that we're referring to the ion, that means that it wants to achieve the octet rule. So it's going to have one more. Now, when it has that extra one, we put it in brackets to represent that, hey, this is an anion. And then we put the negative charge outside because it's saying that it's being like shared amongst the atom is how to show that. So this is for the bromide ion. And then this one would, and then kind of just writing the other one real quick. This would be for the bromine. Then if you were to have, let's say, something that's positive and negative, well, let's say if you had Na, so this would be sodium atom. And then if you had sodium cation, you just write a plus next to it. So this would just be sodium ion in this case. So notice that the ending didn't change for that one. We just wrote sodium, then ion. This is on homework 4 in that one because you got to kind of label what they are. And also in case I didn't mention this earlier, but I'll post all these notes and stuff to Canvas too for you guys. So anything I wrote down, I'm sure there's probably one of you probably has 308 photos on your phone at this point, but all this stuff's gonna be on Canvas, so you have it all. So you don't have to do any of that or screenshots or go through whatever, you'll have everything. Let's see how much I got to zoom on this one. What is the charge of the nitrate polyatomic? So that one should be a pretty easy one because you guys have your green sheet. Okay. So you don't want to get confused between nitrate and nitrogen, right? So nitrogen, you're right, it would be a 3 minus. But when it comes to nitrate or nitrite, so your polyatomics, so your oxyanions, they have a -1 charge for those ones. What is the formula for the molecule formed between nitrogen and chlorine? It actually has to do with Lewis structures. So this is a preview of what's to come. So there won't be a nitrogen chlorine one on that test. Sorry, it's almost 10 o'clock. My brain's like, ah. All right, so with this one, right, we write our dots, right? There's 5 dots around nitrogen, so the 5 valence. And then there's 7 around the chlorine. So this is where they share, right? If I were to look at this, well, chlorine only needs 1 electron. So what can it do? Well, it can bond with nitrogen where it can share one of its electrons to make a bond, okay? And then once we do that, well, I could add more chlorines to do the same thing. So if I do the same idea, right, I have the 7 dots for chlorine. I can also share that 1 electron where they come together, and then I can add in the other one too. And then as a result, they're all going to have a complete octet. So this is covalent bonding. It doesn't take, it doesn't give, they share. So with the 2 dots, whenever the yellow and the purple dots are, this is showing that 2 electrons are being shared. And as a result, when you're looking at these, well, if I highlight maybe in green around chlorine, these are the 8 electrons that chlorine has. For nitrogen, these are the 8 electrons that technically nitrogen has. And then you can see the other chlorine also has 8. And this one also considered to have 8. So they're all happy. Every single one of them. They all have their complete octet. So there's nothing about giving, taking. It doesn't have to get it from anywhere else. So it ends up being a covalent bonded example. So this is what we'll talk about more in week 7. I think week 7 or 8. You see it goes off the Lewis structures. So yeah, I forgot that's in there. So I took that out of this test for you guys because I didn't want to as you all know, it's already overwhelming as it is. So this was like one extra thing that was in there. So I took out covalent bonding like almost all together. Like the naming video is there for everybody for both classes, but I took it out. Like we're not going to really cover it in detail until like a few more weeks. So I separated ionic and covalent. Okay, last one. Oh, we're almost there. Yay. All right, last question. Which of the following electron configurations is impossible? Oh boy, that's tiny. Let's oop, whoa. Oh crap, I just skipped all you guys. I'm so sorry. Oh, which one's impossible? Oh no, I just did not mean to skip that. I was trying to zoom in. Oh, sorry. All right, let's just look at it together then and see if we can figure out which one is impossible. So this is the one that I was kind of referring to earlier when we're like looking at this, like can you try to figure out what's considered to be impossible? So you're like looking at each configuration, seeing if you see anything out of the ordinary. So like 1s2 is good. 2s2, you see an A that there's it's 2s4. So that's letting you know like, ooh, that's wrong. So A is something very, very wrong with A. Then you kind of compare the other ones like 2p6, 3s2, and then all the 3p's, well, that's going between 1 and 6. Now the question was, well, what is impossible? So that one would be A because one of them you can't have 2s4. It stops at 2. So remember it's 2s2, 2p6. Other ways this could be impossible is like maybe if they were in the wrong order, maybe, or like incomplete levels is another thing as well. So those are the kind of questions that's asking. Sorry, that accident I skipped that was an accident. See, like I said, I'm getting tired brain. But all right, it's not 2023 anymore, but it's my 2023 exam, is what that means. I should have not put the year in there, but good job, guys. Nice. Let's B Aubrey. Is that Aubrey? No, that's Audrey, not Aubrey. What was B? What was B? Oh, is that no. Oh, it was Alyssa's on there. I didn't look at all everybody who's left. Yeah. I was like, who can I guess? Oh, it's probably was it Brenda? Are you doing? Yeah, he's like, if it's like, I'll probably be Brenda. I would guess be the most likely case for B. So good job. I don't know who else it would be. They're the only one with a B in your name. And then good job, Catherine and Audrey. Nice. Awesome. Well, good job, guys. Well, that was one of my old exams. So I know it was a lot longer than I thought this would be. I thought it would just take like an hour, maybe 2 hours to kind of go through that, but I hope that it helped. Kind of going through an old test and kind of reviewing all those things and going through them. Is there any like last minute questions that anybody has at all? Like, I don't know, anything that I think that was kind of covered all the major areas of the test that I can think of. I'm gonna look at the test real quick just to make sure that, I have this is not something I haven't said that I'm gonna be like, I'm gonna regret that later. Will there be period naming, group naming? There could be. I mean, that's possible for sure. I mean, you should know at least like you should know those four groups, I think, like the alkali, alkaline, halogens, noble gases. I think that's pretty valuable to know those names. They're so common in terms of like the everyday world and like in terms of being used in not only chemistry but bio, that the terminology comes up a lot. So I think it is helpful to know them, especially for later classes. Yeah. Okay, Russian. Oh, thank you so much. I'm like, I was like, I gotta eat dinner. I haven't eaten dinner yet. So that's why I'm like, I'm just kind of starting to lose it. Um, so I know, right? That's I never remember to eat, never remember to feed myself. But I hope it's helped. Send me messages if you guys need help while you're studying and stuff. Absolutely, and for your homework and all that good stuff. Okay. And then, yeah, if being that so many people help with this one, and if maybe I'll send you guys like ask you guys how it helped and stuff. And hopefully you guys grade. So study, make sure you guys study like a lot of put hours, hours and hours. And that doesn't mean like watching Netflix while studying, like or blasting music while studying. Like try to focus. Lo-fi is okay, but don't go ham. All right, guys. I hope you all have a good night. I'll see you all later and let me know if you guys need anything at all. All right. All right. Bye now. See you.